Hello. Hello.
Yes, sir.
See, yesterday we discussed about the de Broglie theory of matter waves. No? Today we'll discuss about the photoelectric effect. Photoelectric effect. Okay. Okay, fine. In this photoelectric effect, initially we are having an metal surface. Okay. Preferably it is alkali metal. Okay. Having the electropositive nature. Okay, let us consider a metallic surface. Okay, or alkali metallic surface. Okay, that means we need a metallic surface which can easily emit the electrons, Okay. Okay, fine. In the metallic surface we'll have the cathode, suppose C, and we are having the anode, this one A, anode. Okay, anode is having an high potential than the cathode, or we can say anode is at high potential. Okay. Okay, whenever it is connected to a battery, whenever it is connected to a battery, okay, it is connected to a battery. Battery is having a potential V. Battery is having a potential V. Now, before going to see the photoelectric effect, here we are having the two statements. Okay, first one, it is Head's statement. Heads. Okay, whatever the unit of name, it is the scientist name, that is Heads. Heads explain that whenever an microwave radiation is incident is incident on the metallic surface, then electrons residing at the cathode will emit and reaches to the anode. Okay, and battery, it is having a minimum potential. Say for example, it is from 0 to 2 volt, 0 to 2 volt. Okay, whenever an microwave radiation, okay, I think all of you knows about electromagnetic spectrum. In the electromagnetic spectrum, you can see, firstly we are having microwave, radio waves, and then infrared, okay, visible, x-rays, gamma rays, cosmic rays, like this. Different regions of radiations are there. Different regions of radiations are there. Okay. Okay. Whenever a microwave radiation is incident on the cathode, electrons are emitted. Okay. Here electrons are emitted with respect to the light energy. So whatever the emitted electrons are there, we are calling it as photoelectrons. And the current is produced due to the emission of electrons from the cathode. Okay, which we are calling it as photoelectric current. Photoelectric current. Since the incident radiation is small, okay, so photoelectric current or number of photoelectrons will be very small. Okay, okay. And then next another one came, and the Planck came and he explained that instead of microwave, he incident with an infrared. Okay, infrared radiation. Okay, okay. The frequency of infrared is somewhat high than the microwave. Okay, again, even for the infrared radiation also the same thing. But the number of photoelectrons increases. The number of photoelectrons increases. As the whenever an infrared radiation is incident on a metallic surface, okay, electrons are emitted from the cathode and reaches to the anode. The emission of electrons, okay, emission of electrons from the metallic surface, okay, with the supply of external light energy or infrared radiation, okay, can be called as photoelectrons. Okay. Now Einstein explained that, okay, whenever if it is visible radiation, if we incident the visible radiation, then electrons will be emitted. Suppose let us consider E is the energy of the incident radiation. E is the energy of the incident radiation. Okay. Okay. Incident radiation will have an combination of light rays or a single light ray. Incident radiation. Suppose if the incident radiation is having only one light ray, okay, according to the Planck quantum theory or Planck's theory, it is a light ray will travel in the form of a photon, in the form of a photon. Okay, so for one light ray, I can write it as energy. I can write as h nu, where nu is the frequency of incident radiation. That is nothing but hc by lambda. If we are having an bunch of light rays, then I can write it as E equal to nh nu. That is nothing but nhc by lambda. Okay, now. Hello. nhc by lambda. Umar.
Yes, sir.
Okay. Okay. This much of light ray is incident, okay, on the metallic surface. On the metallic surface. Okay. Energy E equal to nhc by lambda. Okay. Now, whenever the energy is incident, observe carefully. Okay. Initially, Hertz explained about microwave, infrared, visible. Why Einstein, okay, stopped at visible only? Okay, we are having in the electromagnetic spectrum up to gamma rays, means every metallic surface, okay, will allows, okay, up to a fixed radiation. Okay, that means depends upon the resistance and capability of the metallic surface. Of the metallic surface, each metallic surface, okay, will have an limitation. Will have an limitation. Okay, suppose if the metallic surface needs 10 power 5 joules, if I am giving the 10 power 8 joules, then the metal will not absorb the energy because huge difference is there. Approximately 10 power 5 means metallic surface can absorb the energy. But if you supply greater than 10 power 5, like 10 power 8 or 10 power 9 order, then metallic surface will not absorb. Will not absorb. Okay, okay, fine. So whenever the energy is incident, then what will happen? Initially, electrons are leaving the cathode and moving towards the anode with a velocity v. With a velocity v. That means due to the supply of incident radiation, initially electrons are having the kinetic energy. Electrons are having the kinetic energy. In turn, I can write as kinetic energy of the electrons as half mv square, where m is the mass of electron. What is the value of mass of electron? What is the value of mass of electron? Mass of electron value
9.1 into 10 power minus 31 kgs.
9.1 into 10 power minus 31 kg. Remember the value in this chapter. Again, in the next chapter, atomic physics, will use it. Okay. In the next chapter, atomic physics will use it. Okay, fine. Now, here it is that, okay, here it is that whenever the electrons are moving, then what will happens? The minimum energy required by the electron, to escape from the metal, right? Okay, fine. So the minimum energy required by the metallic surface or by the metal, okay, to escape electrons from the metallic surface can be called as work function. Okay, K is kinetic energy of electrons. K is kinetic energy of electrons, and W naught, okay, can be called as work function. Work function is defined as it is the minimum work required by the metallic surface to escape the electrons from the metallic surface. This work function can also be indicated with the phi naught. Can also be indicated with phi naught. Okay. Okay, fine. Now, see here it is that according to the definition of work function, okay, it says that minimum work required by the metallic surface to escape the electrons from the metallic surface. Okay, so work required to escape the electrons. So from the preliminary studies, we know that potential is defined as work required to bring a charged particle or positive charge from infinity to the given region. Okay, so work done I can write as charge times potential. Similarly, okay, work function I can write it as charge of the electron times potential. Minimum potential applied, here it is, this one. Minimum potential applied to the metallic surface to escape the electrons from the metallic surface. To escape the electrons from the metallic surface. Okay. Okay, fine. Now, here it is that it is, I can write as E into V naught. The same work done I can write as work done will be in the form of energy. Suppose if one electron is escape from the metallic surface, I can write as H into nu naught, where nu naught is the minimum frequency required by the metallic surface, to escape from the metallic surface. Okay, fine. So W naught I can write as H nu naught. Okay. This is the minimum frequency which is allowing the electrons to escape from the metallic surface. So this minimum frequency can also be called threshold frequency or cutoff frequency. Now, firstly, see what is the cutoff frequency or what is the meaning of cutoff. Okay, what is the meaning of the cutoff? Okay, okay, fine. Firstly, see before 10th class or even in your plus 2 or intermediate, you can see in any subject, okay, to decide whether the student is pass or fail, it is the mark, it is 40. So cutoff mark, it is 40 marks for 100. Okay, for maximum mark 100 mark, cutoff mark it is 40. That means the students who got greater than 40, okay, the officials, they will decide that the student got passed. If it is less than 40, they will decide that it is student got failed. Okay, Okay, fine. Now, this cutoff plays an important role in your competitive entrance exam. You can see anytime they will give the cutoff mark. Okay, suppose if it is JEE mains, if we consider the JEE mains, out of 300, every year they will announce cutoff mark. Every year they will announce the cutoff mark, right? Anytime here, cutoff mark. Anyone knows cutoff mark in any year, at least in 2020 or 2019, cutoff mark. What is the cutoff mark? Generally, it will varies from 80 to 120. 4 years back means cutoff mark it is 120. Okay.
Sir,
Madam.
link to a draft.
Okay. Eighty to 120. That means in this cutoff mark, you can see the student, suppose if the cutoff mark is 120, the student who got greater than 120 marks in the JEE mains, they will say that students are qualified. Okay, this is only for qualifying mark only. Okay, qualifying mark only. The student who got less than 120 marks, they will say that it is not qualified. Not qualified. Okay, fine. Okay, so like that here also we are having a cutoff value, or it is the minimum frequency. Okay, less than this minimum frequency or less than this nu naught. Okay, less than this nu naught, electrons will not emit from the metallic surface. Electrons will not emit from the metallic surface. Okay, so here we are having the observe the phenomena. Whenever the energy or whenever the incident radiation, okay, is incident on a metallic surface, then initially electrons are ejected or emitted from the cathodes, from the cathode, and reaches to the anode, and reaches to the anode. Okay, okay. So in moving from cathode to the anode, in moving from cathode to anode, electrons are having the kinetic energy. Okay. Now, with respect to this battery, okay, it is the minimum potential to escape the electrons from the metallic surface. To escape the electrons from the metallic surface. So here we can say that equation it is kinetic energy plus work function. That is E, it is the incident energy due to the incident radiation. So I can write as H nu. I am considering only one light. Okay, H nu. Kinetic energy, that is half mv square, plus work function, that is charge times
Minimum potential.
very minimum potential. I can write E into V naught or H nu naught, right? Okay, depends upon the input quantity. Either I can substitute with respect to potential or with respect to frequency. With respect to potential or with respect to the frequency. Okay. Suppose if I substitute with respect to frequency, you can see half mv square plus h nu naught. Okay, okay. This equation, okay, can be called as Einstein's photoelectric equation. Einstein's photoelectric equation. Photoelectric equation. Okay. Okay, fine. Now, if you observe carefully, the Einstein's photoelectric equation leads to conservation of energy. Energy supplied is equal to energy utilized, right? Hello. Energy supplied is equal to the energy utilized. Okay. Okay, fine. Now I can write it as H times nu minus nu naught is equal to half mv square. That is nothing but kinetic energy. Half mv square means kinetic energy. Now, under which condition kinetic energy will be maximum? Under which condition kinetic energy will be maximum? Okay. When it will happen? Shenmukh.
Sir,
When kinetic energy will be maximum?
more frequency light వచ్చినప్పుడు.
More frequency. Next, Umar.
V is greater than V naught.
Huh?
V is greater than V naught energy.
V greater than?
V naught.
See, H nu naught, it is the minimum work required to escape the electrons. Right? Suppose if I am having 10 electrons in a metallic surface, okay? Out of these, if I am removing 2 electrons, that is due to this work function, okay, 2 electrons are removed. Here we are having 10 electrons. Okay, so kinetic energy is produced due to 8 electrons only. Now I want to have the kinetic energy of all the 10 electrons. That means this work function must be 0 or this work function must be minimum, right? I want to have the maximum kinetic energy. So when H nu naught is minimum or approximately equal to 0, then I can have the maximum kinetic energy. Is it right?
Yes, sir.
So while doing the numericals, they will ask to find maximum kinetic energy. Maximum kinetic energy means, okay, we are having incident energy minus work function. So this work function must be minimum. Work function must be minimum. Then kinetic energy will be maximum. Then kinetic energy will be maximum. That is number 1. And number 2 will have the intensity. Okay, intensity. Intensity is defined as amount of energy absorbed or emitted. Okay, amount of energy absorbed or emitted. Okay, per unit area and per unit time. Per unit area and per unit time. So intensity it is defined as energy absorbed or energy emitted per unit area and unit time can be called as intensity. Okay. With respect to the metallic surface, that is cathode, I can say that here energy is absorbed. Okay, energy is absorbed. Okay, so we can write it as E by 8. Okay. Suppose initially I'm having the number of photons as 1. and thereafter I am increasing it. Let us consider to 10. Let us consider to 10. As the number of photons increases, what will happen to intensity? What will happen to the intensity?
Increases.
Right? Increases. Okay. That means as the number of photons increases, okay, energy of the incident radiation increases. Due to that, intensity will be increases. Okay, fine. That means here you can see on the cathode surface, initially I'm having only one electron is emitted or ejected. As the intensity increases, more number of electrons will be ejected. More number of electrons will be ejected. So that means as intensity increases, I can say that photoelectric current or number of photoelectrons will also be increases. Photoelectric current also increases, right? Hello? Can I say?
Yes, sir.
Now here you can see that this energy, okay, will or may convert from light energy to electrical energy. Electrical energy, I can write it as, okay, electrical energy. Power means potential times current. So energy equal to VIT. So obviously intensity is proportional to current. Intensity is directly proportional to current or photocurrent. Okay. Photocurrent I will indicate with small I, and this one I will indicate with I. Okay. As the incident frequency increases, photocurrent increases. As photocurrent increases, intensity will also be increases. Okay. For this, we are having a graph. This is photocurrent. Okay. Here it is intensity. Or we can take incident frequency. As the incident frequency increases, intensity will also be increases. Okay. Since it is directly proportional, it is in the form of y equal to mx. Y is equal to mx. That's why the shape of the graph, it is a straight line passing through origin. Passing through origin. You can see. Okay. When there is no intensity, okay, there will be no photoelectric current or no photoelectrons are emitted. But generally what will happen whenever we incident radiation, okay, first very few time, this cathode will absorb the energy and thereafter electrons will be ejected. You can see whenever you switch on any device, electrical device, suppose if it is TV, whenever I switch on, if you observe carefully, every TV will take a minimum time of 15 to 20 seconds. After 15 to 20 seconds, then the screen will come. Anytime observe.
Yes, sir.
Okay, that is the minimum potential or minimum energy required. Okay, that whenever the device, okay, is having 1 volt, then only the screen will glow. Till that 1 volt, the screen will not glow. That 15 to 20 seconds, the voltage is growing from 0 to 1 volt. In that stage, it will not glow. Similarly, here also, every metallic surface requires a minimum potential or minimum energy. Okay. In that phase, none of the electrons will be ejected from the metallic surface. From the metallic surface. Okay. That we are calling as threshold or cutoff, minimum value. Whenever the applied potential is greater than 1 volt, then it will start. Then it will start its motion. Okay. Okay, fine. This is the first graph. Second one, it is potential versus current. Suppose this is current and this one it is potential. Okay. Sorry. Here it is current. On y-axis, let us take current, and on x-axis, take potential. Okay. V, it is the potential. Okay. Up to a minimum potential, there will be no current. There will be no current. Current will be 0. Okay. After crossing the minimum potential, that is V naught, as the potential increases, current will also grow. Current will also grow. Okay. Okay. Whenever we connect in reverse bias, in the reverse bias also the same thing. Up to minimum potential, it will be. There will be no photocurrent, and then immediately it will come. Okay. So 0 to V naught, observe carefully, 0 to V naught. This region, we can call it as cutoff region or threshold region, where there is no participation of activity by the electrons. Okay. And here it is, you can see, as the potential is increasing, current, photocurrent is also increasing. This is the region of active region. Active region. Okay. Okay. As the potential increases, current will be increases. Okay. At a particular value, if I increase the potential, photocurrent will not be increases. It will become as constant. It will become as constant. Okay. Whenever it comes to constant, this region can be called as saturation region. See, the same thing we have studied in the semiconductors, in the PN junction diode. Anyone remember? You can see the graph. You can see the graph. Okay. Okay, fine. Once open your material. Hello. Once all of you open your material. And next one, we are having that it is, this is the incident frequency. And here it is the potential. Potential or current. Okay. Whenever we are having the minimum potential, that is nu naught. Okay. No current will be there. No current will be there. Okay. Once all of you open your material, photoelectric effect. Photoelectric effect. Right? Okay. What is the page number?
$210.
210.
No. See. Here, see, first one in the first paragraph. Okay. Before going to first paragraph, okay, see the point, that is C. Photoelectric emission. Okay. Photoelectric emission. Okay. Now this is Leonard's experimental study. Just give one reading. Okay. Not that much important. Okay. Not that much important. Okay. In the photoelectric effect. Okay. See the second point and the third point. Fourth point, it is the definition. That is emission of electrons from a metal plate when illuminated by electromagnetic radiation of suitable wavelength. Okay, all of you underline that one and must read and remember. Most important, this photoelectric effect with respect to IPE means they will ask in either in 4 mark or in 8 mark question. Okay. In JEE mains and BitSat and MSAT. Okay. JEE mains means every time they are asking one question. Sometimes they ask the 2 questions. Even in the JEE advanced also. From this chapter, they may ask 8 marks on photoelectric effect. On photoelectric effect, most important chapter for JEE mains, advanced and BitSat and MSAT. This topic is most important, utter most important. Okay, number one. And number two, it was that, okay, see here, Leonard's experimental study, once give the reading. Okay, see the diagram, we are having a cathode and an anode. Electrons are reaching or moving towards the anode. Okay, and here we are having a light of wavelength. Okay, okay, microammeter you know. And below to that, we are having a variable resistance. Below to that, we are having a variable resistance or rheostat. It can be called as rheostat. Below to that rheostat, we are having a plug key and a battery. Okay, plug key and the battery. Okay, in this experimental study or experimental observation, below to the diagram, see the, I'll consider it as first point. 1, 2, 3, 4, 5. 5 points are there. 5 points are there. See the first point. When key is open and monochromatic light is made incident on the cathode, then current is measured by ammeter. Even though applied voltage is 0, current flows in the circuit. Right? Okay. Next, these photoelectrons emitted from the cathode moves towards the anode. Okay. Okay. When second point, when anode is given positive potential, okay, with respect to cathode, electrons in the space charge are attracted towards the anode. So photocurrent increases. Okay. In this topic, you should understand when or under what conditions photocurrent will be increases and when photocurrent will be decreases. Second point, all of you underline. All of you underline. If the potential of anode is increased gradually, then the effect of space charge, that means the potential at the anode is increased. Then what will happen? Okay, number of charges accumulated at the anode, okay, will be decreases. Because already here I am having a potential. If I am increasing it, that means I am bringing some charges from infinity. I am increasing the potential of anode. It means that I am bringing the charges from infinity to the anode. Okay. In addition to these electrons, we are having some positive charges. That's why they says that it is. They says that if potential is increased gradually, effect of space charge becomes negligible. At some potential, then every electron that is emitted from the cathode will be able to reach anode. The current then becomes constant even though voltage is increased. Next, when the anode is given negative potential, that is in reverse bias. The previous point he explained in forward bias. Now it will be the reverse bias. With respect to the cathode, the photoelectrons will be repelled and some electrons will go back. So current will be decreases. Okay. The second point and third point, forward bias and reverse bias, must remember. Most important. Sometimes they asked about the theoretical question or conceptual based question. For that, it is very useful. For that, it's very useful. Okay. Okay, fine. Okay, second point and third point. And the fourth point, the minimum negative potential given to the collector. Here, collector means, okay, anode will act as a collector. Cathode will act as an emitter. Cathode will act as an emitter. See, in the transistor configuration, we studied about collector, base, emitter, which will emit the electrons. Okay. So, the minimum negative potential given to the collector with respect to the emitter, for which photocurrent becomes zero, is called stopping potential. All of you underline it and once again write in your notes. Most important definition, stopping potential. They are asking in 2-mark question. They are asking in 2-mark question. Cutoff potential, stopping potential, or threshold potential, all are the same. Stopping potential is related to, see, maximum kinetic energy of photoelectrons. Because at this potential, even most energetic electron fails to reach the anode. Okay. Now, here we are having the graph, you can see. On x-axis, we are having potential. And on y-axis, we are having the photocurrent. Whenever the anode potential is zero, we are having an photocurrent. Suppose here we are having the, on x-axis, we are having anode potential. Okay, V. When anode potential is zero, we are having a current, photocurrent. Right? Okay, this photocurrent is due to the incident radiation. Incident radiation. As the potential increases, current will also be increases and reaches to an saturation value. Reaches to an saturation value. Okay, fine. Now, as the potential decreases, what will happen? Current will also be decreases. At some point, current will comes to zero. That is, all the electrons will comes to rest. All the electrons will comes to rest. Okay. And here you are having the experimental observations. That is, all of you remember these graphs. Variation of photocurrent with intensity of light. Okay. As the intensity increases, photocurrent is also increases. Photocurrent increases. Okay. Fine. Hello. Akyutin.
Yes, sir.
Varshit. Right. See, as the intensity of light increasing, okay, then photocurrent is also increases. Photocurrent is also increases. That is this one. Now, variation of saturation photocurrent with stopping potential. With stopping potential. Okay. As the potential increases, see this one. Okay. As the potential increases, what will happen here? Initially, when potential is zero, we will have an photocurrent. This is due to incident radiation. Even though potential is zero, we will have the photocurrent because of incident radiation. Okay. As the potential increases in the forward bias, okay, current will also be increases and reaches to an saturation value. Thereby, after reaching the saturation value, if we increase the potential, current will not be increases. If we decrease the value, as the potential decreases, what will happen? Current will also be decreases. Okay, this is the minimum potential, that is minus V naught, which is required by the cathode. Okay, and then observations. And finally, we are having variation of frequency of incident light on stopping potential. Okay, similar to the above. Similar to the above graph. That is, when anode potential is 0, current will also be, current we are having a finite value. And below to that, we are having observations. Remember these two observations. Next, final graph, it is stopping potential with respect to frequency. For each metal, suppose if I consider lithium, sodium, potassium, rubidium, okay, for each metal, work function will be different. Work function will be different. So that is, threshold frequency will be different. Threshold frequency will be different. Even though all are from the same group, alkali metals only, but due to the number of electrons, okay, will have the, it is in lithium, it is in valence electron, it is in 1s2, 2s1, right? Second orbit, third orbit, okay, like this. So due to that, okay, we'll have the stopping potential will be different. Stopping potential will be different. Okay, that is the graph. You can see the observations. And remember the laws. Sometimes in the laws of photoelectric effect, they asked in the 2-mark question. Okay, the 2-mark question. That is, entire the page of from 210, 211 and 212. It is the photoelectric effect. It is the photoelectric effect. Till the laws of photoelectric effect. Till the laws of photoelectric effect. Okay. They will ask the question that it is, what is meant by photoelectric effect? Explain in detail about experimental observations of photoelectric effect. Describe laws of photoelectric effect. Hence, derive an expression for photoelectric equation. 8 marks. They may ask in 8 marks, or they may ask in 4-mark question. Okay. Every student must read and remember. Without reading photoelectric effect, don't go to IP exam and don't go to JEE mains. That much important is there. That much importance is there. Okay. Okay, fine. And next, turn the page 214. We are having here Einstein's photoelectric equation. Can you see? Hello?
Yes,
Roman?
sir.
Arpichinda? Okay. See, you are having the equation half mv square, that is kinetic energy maximum. Maximum kinetic energy, incident energy minus work function. Incident energy minus work function. Okay. Okay, fine. That is, here you are having the examples. Okay. Here you are having examples. Okay. Afterwards, you can see that one. Afterwards, you can see that one. Okay. So we have completed this photoelectric effect. Okay. And then de Broglie is also completed. Okay. Heisenberg, okay, division and Germer. Division and Germer experiment is there. And next one, it is Heisenberg uncertainty principle. Okay. Never they have been asked. Okay. In physics, they didn't ask. But in the entrance, they didn't ask. In the IP, sometimes they asked in the 2-mark question. According to Heisenberg uncertainty principle, it says that it is impossible to find momentum of a particle and position of a particle at the same instant of time. At the same instant of time. Okay. It is impossible to find position of a particle and momentum of a particle. Okay. I think in chemistry you might study it. Delta x and delta b, it is greater than or equal to h by 2 pi. H by 2 pi. And another one, it is impossible to find energy and time. Okay. at the same position, okay, at the same position or at the same instant. And it is impossible to find angular momentum and angular displacement, okay, at the same instant of position and time. Position and time. That is what Heisenberg uncertainty principle. Heisenberg uncertainty principle. Okay. Okay. Go to module 1. Module 1. See the module 1. Open it. Page number. What is the page number?
228.
228. Now, see the first question. See the first question. See, already I shared the chapter wise 2 mark, 4 mark, 8 mark questions. మీరు చదవాలి అనుకున్నారు, అది ఎక్కడున్నా చదువుతారు. ఆల్రెడీ మీకు క్వశ్చన్స్ ఇచ్చేసాను, మీకు మెటీరియల్ ఉంది. ఆ చాప్టర్ తీసుకోవడం, మీరు చదువుకోవటం. ఆ క్వశ్చన్ మీకు అర్థం కాలేదు, ఎవరైతే వస్తున్నారో వాళ్ళు అడగండి, చెప్తారు. ఓకే, లేకపోతే నాకు సార్ ఇంకా క్వశ్చన్ చెప్పలేదు, ఇంకా తర్వాత చదువుతాను, ఇట్లాంటి ఏదో ఆన్సర్లు చెప్పాను. ఓకే, అమ్మాయి అబ్బాయి అనుకోండి, నేను చూడు నట్టి ఇళ్ళ కొట్టడమే. ఓకే, ఆల్రెడీ మీకు ఏ క్వశ్చన్ చదవాలి, లేకపోతే ఆ ఇంపార్టెంట్ క్వశ్చన్స్ అన్నీ ఇచ్చేసాను, చాప్టర్ వైజ్గా ఇచ్చాను. మీ దగ్గర మెటీరియల్ ఉంది. మీకు ఏదైనా క్వశ్చన్ అర్థం కాలేదు, సార్ నాకు ఈ వర్డింగ్ అర్థం కాలేదు, లేకపోతే ఈ పారాగ్రాఫ్ అర్థం కాలేదు అంటారా, పట్టుకురండి, అని నేను చెప్తాను. అంతేగాని నాకు ఏదో యాక్షన్ చేసి నాకు ఈ క్వశ్చన్ నాకు తెలియదు సార్, లేకపోతే ఏ క్వశ్చన్ చదవాలో నాకు తెలియదు సార్, ఇట్లాంటి కుంటి సాకులు అని చెప్పారనుకోండి, వాళ్ళకి మాత్రం గ్యారంటీగా పడతాయి గేర్ రాడ్. ఓకే, నెక్స్ట్ ఉమర్. ఉమర్, మన వర్కింగ్ ఎక్కడ దాకా వచ్చాం? ఏసీ అయిపోయిందా? అసలు
వేవ్స్ అయిపోయింది, ఏసీ చేయాలి.
వేవ్స్ అయిపోయిందా? సరే పోనీ, ఏదో ఒక చాప్టర్ అయింది కదా, ఒక చాప్టర్ అయింది. షణ్ముఖ్
సార్
మన పరిస్థితి ఉందన్నా?
చేస్తున్నా సార్.
ఏది, ఏసీనా వేవ్సా?
మ్యాగ్నెటిజం చేస్తున్నా.
సరే, see the first question. The frequency of a photon associated with an energy. Okay, we need to find frequency. Okay, with energy 3.31 electron volt. Okay, they gave the energy and asking to find frequency. That means E equal h nu. So nu is equal to E by h. Okay, and remember that 1 electron volt, see 1 electron volt charge into potential. Charge value it is 1.6 into 10 power minus 19 joules. 1 electron volt equal to 1.6 into 10 power minus 19, 10 power minus 19 joules. So 3.31 into 1.6 into 10 power minus 19 by h, they gave it as 6.62 into 10 power minus 34 heads. Correspondingly, you can get the value. Okay, you can do calculation later. Okay, write down the hint and leave some gap. Okay, for calculation. Second one, a radiation of wavelength, that is lambda equal to 2500 angstrom, is incident on a metal plate whose work function is W naught, 3.5 electron volt. The potential required to stop the fastest photoelectrons emitted by the surface. That means we are having the photoelectric equation as incident energy equal to kinetic energy plus work function. Incident energy I can write as hc by lambda. Can I write? Is equal to kinetic energy plus work function they gave already. Here kinetic energy means, okay, the energy possessed by the electrons or photoelectrons ejected from the cathode. Antena? Is it right? Is it right? See, the potential required to stop the fastest electrons. Okay, to stop the fastest electrons, we need to find the potential. So I can write it as Hc is equal to E into V plus W naught plus W naught. So Hc by lambda, okay, equal to EV plus W naught. Okay, substitute the values, find out the value. Hello. Good morning. हाँ? कुछ नहीं क्लास में नहीं मेरा क्लास सुबह 6 बजे को शुरू होता है नहीं मैं YouTube में क्लास कर रहे वो लिंक देता हूँ देखो मेरा क्लास का लिंक है नहीं अभी का आएगा अभी ब्रेक आएगा 9 से 10 आएगा 9 बजे को आएगा और तुम खाया एक्सेलेंट और घर में कैसे है और नहीं मैं ठीक नहीं तुम उधर है ना इसलिए तुम इसलिए तुम उधर है ना ऐसा नहीं तुम करेगा ना क्यों क्यों मेरे को टेंशन तुम उसी एंडिंग है यार मेरे को क्या ला रहे हो और काम हो गया नहीं हुआ वो करते बोला क्यों टेंशन क्यों तुम हाँ वो देखा है ना मेरे को चार्ट मॉडल बोला और चार्ट मॉडल रेडी करो मैं बाद में 10 तारीख को फाइनल करता बोला मैं क्या सोचा तुम 10 तारीख तक आएगा ना फोटो रखेगा वो फाइनल कर राइट ना। इसलिए एक वीक का रुको, थोड़ा सा काम है इसलिए बाहर को आया। मैं बोला 10 तारीख को आएगा, उस टाइम को मैं फाइनल कर पाऊँगा। उसको एडवांस दिया। हाँ अच्छा है। यस वेरी गुड सुपर। बेटा कौन? श्रीकांत वो ठीक नहीं, नहीं ठीक नहीं, नहीं इसका मेडिसिन एक ही पास है। उसका मेडिसिन एक है। Okay. वो तुम रहते हैं ना लॉकडाउन का, वो उतना सीरियस नहीं है बोलते। और सुबह सुबह याद किया। तुम बहुत क्लेवर है, दिमाग है। नहीं नहीं मेरे को दिमाग नहीं है। बोला ना। और कुछ नहीं, ऐसा चल रहा है। एक कॉलेज का आया बैंगलोर का, प्रेसिडेंसी कॉलेज। उसका 20 एक्टर्स में कॉलेज है, 20 एकर्स कॉलेज। वो कॉलेज का क्लास का पूछा आज फाइनल करेगा बोले। वो आ गया तो अच्छा है। वो वो 3 BHK फ्लैट देते हैं। 3 BHK फूड भी, खाना, लंच, डिनर, ब्रेकफास्ट, स्नैक्स पूरा वो देता है। पैसा भी देते हैं, 1.5 देता है। हाँ हाँ इस साल का ऑनलाइन बोला, अगला साल से ऑफलाइन सोचेगा सर। ओके ठीक है सर, ठीक है। वो एक नारायण कॉलेज का वाइस चेयरमैन रेफर किया। सेकंड में 3 फैकल्टी को देखा, वो मेरे को पसंद नहीं है, तुम आएगा तो अच्छा। मतलब सर तुम बोला मतलब मैं एग्री होता है सर। कितना है, पैसा कितना दिएगा? आप ही बात करो सर, मेरे को इतना नहीं सर। तुम श्रीकांत इतना काम इतना पैसा आता है। वो बोला, सिर्फ वही बोला सर, मैं कुछ नहीं बात करता हूँ सर, इसलिए तुमको बोला। क्या? ओके सर, मैं फाइनल करता हूँ। टुमारो विल गेट फाइनलिस्ट। बट अच्छा कॉलेज है, ऑलमोस्ट 30 इयर्स हो गया, अगला साल प्लान करता हूँ बैंगलोर का। फूडिंग एंड बॉडी, फूड एंड बॉडी पूरा उन लोगों का। वो क्या आता है, वो पूरा बैंक में रहता है, पूरा पकड़ 1.5 मिनिमम 1.2 1.3 मैक्सिमम 5 लाख से 10 लाख कर देते हैं। 2024 question. तो नहीं तो मैं आता हूँ. टी नहीं मिलता ना, टी काफी लाएगा. सब कुछ ज्यादा. मतलब चर्बी से